Okay, you guys, we've arrived. This is the last lesson of Module 3. Actually, Module 3 is like the shortest module, so don't feel that accomplished, okay? But we did arrive at the end. This is Module 3, Lesson 16, the very final lesson in Module 3. And we're going to be using it to help us get ready for our Module 3 test, which is going to be on Friday. Today's learning goal says, I can use tape diagrams, we know a lot about tape diagrams, to help me explore or to help me study part-to-whole relationships. So when we talk about fractions, we know that a fraction is a part of a whole, right? If I only give you 1/2 of a pie, I'm only giving you half of the whole pie. Today we're going to be really looking at how we can use drawings, how we can use tape diagrams to help us express or show what a fraction really means. Your problem of the day says, okay, please draw a tape diagram, or maybe 3 tape diagrams, that depict this situation. There are 3 roads, road A, road B, and road C. We know that road B is 3 times longer than A, and C is twice as long as B. So here's how you might draw it. I'm going to start by drawing road A. Does it tell me exactly how long road A is? No, it really doesn't matter though. Now, what do we know about road B compared to road A? It says road B is 3 times longer than A. So I have to draw B where this is, right now, is B 3 times longer than A? How does B compare to A right now in my drawing? It's the same length. What if I do this? Now how long is B compared to A? Now B is twice as long as A. What does the situation say? It says B is 3 times as long as A. So this is how I can make B 3 times longer than A. Now for me, I don't have the luxury of having little graph paper graphs on my paper, right? So I'm estimating. Do you have graph paper graphs? So could you make your drawing exact? You sure could. Just count the little boxes. Now what do we know about C? C is twice as long as B. I'm going to run out of room, so I'm going to shrink mine. Okay, now, first, if I know C is twice as long, I'm going to first draw the same length as B, but I have to make it twice as long as B, so it has to be 2 times of what B is. And that's how I can draw tape diagrams that depict the described situation. The directions tell us to draw some ribbons. What they mean by ribbons is tape diagrams. Okay, you can call it many things: rectangles, tape diagrams, pictures, math pictures. Okay, it tells us to draw 1 ribbon, and it says, okay, the piece shown below right here is only 1/3 of the whole. So if this is 1/3 of the whole, how big would the whole be? How many third-sized pieces would you need? 3 total, so 2 more. So in order to, it says complete the drawing to show the whole ribbon, well, I would need to take that and draw 1 more piece and 2 more pieces, because each of these is 1/3, 1/3, and 1/3. So therefore, that is the entire ribbon. Part B says we're still going to draw 1 whole ribbon, okay? The piece shown below is 4/5 of the whole. We want to show the whole. So if this is 4/5, well, okay, let's think about the fraction 4/5 for a moment. Oops. What size is the unit? Fifths. Our units are fifths. How many fifths do we have? 4. So that tells me that in this piece of ribbon that's shown right here, there's 4 pieces, and each piece is 1/5 big. So if this is 4 pieces, I have to first divide it into 4 pieces, don't I? Because my numerator tells me there's 4 pieces. So if I divide it like that, how many pieces do I have right now? 2. If I divide it now, I have 4 pieces. Yes? 1 piece right here is how big? 1/5. It tells us right now our unit is 1/5. So if this is 1/5, this is 1/5, this is 1/5, and this is 1/5, how much do I have to add on to draw and make the whole piece? 1 more fifth. So I know the size of 1/5 is like that. And so that's the entire ribbon. And what you might want to do is label that each of those pieces is 1/5. In part A, each fraction was 1/3. So our units was 1/3. And it told us how many of those thirds did we have already? 1. So that's why we had to add 2 more, make 2 more copies of it. But down here, our units were fifths, and the fraction told us we had how many of those fifths? So this piece was already 4 small pieces. So we had to first divide it into small pieces 4 small pieces so that we can find out how big 1/5 should look. Does that make sense? Great. Okay, question number 1C tells you this time you need to draw 2 ribbons. Okay, one ribbon is going to be called ribbon A, and one ribbon is going to be called ribbon B. It tells you that 1/3 of A is equal to all of B. So, we can draw ribbon A. Just label it. And then it tells us that 1/3 of A is equal to all of B. So is B bigger or smaller than A? Smaller. What we'll need to do is show 1/3 of A, and B is the same size as 1/3 of A. You can see that these ribbons meet the requirements. 1/3 of A is equal to all of B. Do you see that? Very nice. Try problem number 1D. It says to draw 3 ribbons, C, D, and E. C is half the length of D, but E is twice as long as D. The question is asking us to figure out how much longer is Robert's wire compared to Maria's wire. Okay. We know important information is that half of Robert's wire is equal to 2/3 of Maria's wire. And all together, their total length is 10 feet. Go ahead and circle the important information. Now we've done the R. We have to D. We have to draw. So let's first draw Robert's wire. We'll use an R to show that it's Robert's. Here's Robert's wire. We don't really know how long it is right now, but we'll just draw a piece of tape. And then we know Maria has wire too. Okay? What does it tell us about Maria's wire compared to Robert's? Well, half of Robert's wire, so this would be half of Robert's wire. Do you agree? Is that all of Maria's wire? No, it's 2/3 of Maria's wire. So I'd have to split this and show that this is 1/3, and this is 1/3, right? And how would I have to add to make Maria's wire whole? Another 1/3. Very good. Okay. And it tells me that the total length is 10 feet. So how can I show in my tape diagram that the total length is 10 feet? Well, what if I draw another one where I show Robert's wire and Maria's wire, right? And all together, it's what? 10 feet. Now, you might think, how can I figure out how long their wires are? Let me ask you a question. If Robert's wire, half of Robert's wire is 1/3 of Maria's wire, how many thirds altogether is Robert's wire? 4/3. So how many thirds do we have altogether? 1, 2, 3, 4, 5, 6, 7. So 7/3, by the way, that would be like doing this, right? 1/3, 1/3, 1/3, 1/3. That's Robert's part. And here's Maria's part. 1/3, 1/3, 1/3. So 7/3 take up 10 feet. That means 10 feet is being divided into how many equal-sized pieces? 7. How could we figure out the size of one piece then? 10 divided by? Oh, interesting. Can't we? Can we? Do we see down here? Are these pieces all equal? They're all what size? 1/3, right? And so how many equal-sized pieces are there? There's 7 pieces. Watch this. There's 1 piece here, 2 pieces, 3 pieces, 4, 5, 6, 7. If I know all together those 7 pieces are 10 feet, how can I figure out how long one piece is? I can do 10 divided by, good. When I do 10 divided by 7, is that the same thing as 10 over 7? Can we break apart the whole? How many holes are there? 1, and that means each one of these pieces is how many feet? 1 3/7 feet. Now that I know that each one of those pieces is 1 3/7 feet, let's try to answer the question. The question is asking us how much longer is Robert's wire compared to Maria's wire? How many extra thirds are there in Robert's wire compared to Maria's wire? 1. So how 1/3 of the wire is equal to how many feet?
1 and 3/7.
So Robert's wire is 1 3/7 feet longer than Maria's wire. This problem, you would not be able to solve it without drawing these tape diagrams. Do you see that? That's why we need to RDW.